We want to thank everyone for coming today. This is a really exciting day for us. We've been working on this project for about a year and a half. And we're thrilled to be here presenting the 3D Explorer to the world. Dr. Clough made the exciting announcements this morning. You can now download high-resolution Smithsonian 3D models at 3d.si.edu. We also have the 3D Explorer, which we'll be demoing for you here today live. So Adam and I will go over the functionality of the 3D Explorer, and then we have a number of curators who will actually show you how this 3D Explorer is being implemented. So we want to talk about first 3D in general and go over what the technology can mean for a museum. So this project was essentially an experiment for us. We didn't know the outcome when we began this journey. And at this point, we're really thrilled with the amount of stories we're able to tell. And with the support from all of our partners, we're able to do that in a really big way. So I'm going to pass it over to Adam, and he's going to talk about the history of documentation.
So I have to be really careful here. Yeah, I don't want to be too heavy-handed. This is not a pound your fist on the desk situation. But if we consider the transition from painting to photography, the transition from radio to television, the way that we turn over and communicate and document over the years, it means a pretty big impact. And I think it's pretty safe to say that in the museum world, 3D documentation is going to be making a similarly sized impact. And we can say that because we look at other industry. Paul DeBevick, in particular, showed us what happened in Hollywood over the past 20 years or so with 3D documentation. You look at manufacturing, engineering, architecture, medical industry. All these other industries have gone through this cycle and this transition, and I think that it's definitely time that we can start thinking about this seriously at the Smithsonian and in cultural heritage in general.
So what can you do with the data itself? 3D data really separates itself from other forms of documentation. Once we 3D scan a Smithsonian object or research site, we are able to take that data home. We can analyze it in ways we cannot do otherwise. We could take that data, we could print it out in the classrooms. We're working with 4 different high schools around the country with a pilot program where they're 3D printing Smithsonian objects. And we're not just doing sort of the neato wow factor of, look, it's printing in the classroom, but we're working with Smithsonian educators to help tell stories about these objects, to develop STEM curriculum around these 3D prints. So we can bring this data back into the real world, and we can also deliver this content to the world with our 3D Explorer. And that's what we're really excited about and what we'll be talking about here today.
So a little bit more about the construct of the project. When we started doing 3D documentation work, we used to go hunting, and we'd go out to the different museums, and we'd look for cool objects and ideas, and we'd almost make little pitches, and we'd see what we could do. But a year and a half ago, with the initiation of this project, we stopped that, and we started to solicit ideas from all the wonderful people that work at the Smithsonian and ask them what they thought we should do with this technology. And I think that that's been definitely a really, really important change in how we think in terms of making sure this is a collaborative effort. And a couple of the objects that we have here.
Yeah, so we essentially engaged almost every of the 19 Smithsonian museums. So the Smithsonian, as you know, is not one museum, it's 19 museums, 9 research centers. So this is really sort of a random cross-section of our collection. So it's incredibly diverse. We've scanned things as small as Euglossine B. We've also scanned entire archaeological sites in Flores, Indonesia, as well as some amazing objects in the repatriation office. This is a Tlingit whale hat, where we 3D scanned it and a replica was created for exhibit display.
We didn't expect it, but when we solicited ideas, we got a response from Smithsonian Gardens, and we ended up CT scanning rare orchids and associated pollinator insects.
And you can see a giant 3D print of that rare orchid on stage. So we'll talk a little bit about the data. This will be a really quick overview. So when we 3D scan an object, usually we're 3D scanning the surface of that object, sometimes the interior. The raw data itself is essentially a point cloud. It's a text file. So it's a visualization of a text file. Each point has an XYZ value, sometimes RGB if there's color represented. So there's a close-up of the text file. So this is the raw data. So it's important that it's a text file because that means it's archivable. We're the Smithsonian. We want to make sure this data is around for the long term. And we know how to preserve text files, so we're not dealing with proprietary formats here. The next stage in the processing is to essentially connect the dots. So if you play a video game, you've seen a polygon model. So now you can reflect light off of this virtual surface, calculate volume. You could 3D print this object. It's also possible to add color back onto the 3D model. And we are not getting into specularity yet, like Paul Debevec has been, but we're hoping to do that for our next step. Of course, there's many other different layers of the 3D data, but we just wanted to go over those three main points: point cloud, polygons, and the texture map polygon models.
So that said, we're really excited about premiering the Smithsonian X 3D model Explorer. We want to stress that this is in beta. This is the result of about 8 months of work and development, and we're sure that there are going to be some bugs along the way. We're interested in getting feedback. We want to hear what you think about how to improve this tool. But that said, it's really exciting to think that this is 8 months worth of work. Imagine what another year's worth of work can do, and we hope to continue this without a doubt.
Right, and we also want to have a shout out for Ralph Wiedemeyer, who is the architect for the software, and also Autodesk for making this vision happen. So this is a big deal. There are a number of 3D viewers that are out there right now. You're able to spin the model around, take measurements, but what was really important to us as a museum is being able to tell stories with these 3D models. Again, getting beyond just the fun technical aspects of 3D technology, but that storytelling is really important to us.
So this will be a little bit of a ride. We're going to use the Explorer as a presentation tool now, so we'll emphasize this fact here. There we go. So here's a model. You see the imagery here, and I can operate this as easy as I can operate a PowerPoint presentation at this point. But it's really important to emphasize the fact that we are not looking at streaming video or a PowerPoint presentation. We're looking at real 3D data being rendered online in real time.
So this is all WebGL technology, which means it's plug-in free, so any modern browser, Chrome, Safari, Firefox, you can go to 3d.si.edu, interact with these models, and we'll dive in right now.
So, like I said, this was Tor functionality. I'm just using the arrow key, but at any point, I can actually break out of that mode and navigate freely.
But can you really prove that that's 3D data? I don't believe you.
Let's see. Seeing is believing, Vince. So we've always wondered exactly how large the Smithsonian sunburst is, and it turns out it's 1.35 inches. 34.4 millimeters for those of metric persuasion. So now we're going to check out some of the other models that we have. We're going to do a really, really quick rundown of functionality of the Explorer, and then we're going to leave it to our educators and curators to dive in deep with some specific objects. So this is the Cosmological Buddha. You can see that it can't be understated, the ability to rotate a model on the screen, online, no plugins, anybody with access to the internet. That can't be understated, but we've taken it a lot further than that. So you can see the amount of quality and detail on the surface that you can visualize right now. This is a particularly interesting model because we have color information mapped right now, but if you remove the color information, the low relief carving becomes much easier to read. And then, of course, you can relight. So the idea of raking light is a way to bring out low relief detailed surfaces. And again, these are all tools that I can manipulate at any time. So I can pull up a menu and relight the object. I can use the editor to do some pretty complicated things. But at the same time, I can go back to my library and go to default settings, and I'm back at home. So it's got a whole lot of depth of functionality, but it's also extremely user-friendly.
So right now, we're able also to adjust the material properties. So this may look like a really cool chrome cosmological Buddha, but there may be some real research questions that are being asked. So if you look at what people will do in industry, the automotive industry, quite often if they're 3D modeling a car, they'll add a chrome surface to that car. So then they could look for surface defects or maybe some hidden detail that's hard to see with the real object or with the 3D model with a regular plain material applied.
So something quite interesting happens when you remove lighting altogether. We have a function called Occlusion Mapping, and that's something that helps to emphasize areas of high curvature. So this is no lighting, this is just mapping out areas of different detail. And you can see now that the low relief carving is extremely easy to read all over the entire surface of the model. And once again, this is something that you can manipulate in real time. So there's an interesting question that we quite often get with 3D data, and that is, okay, so what does the object really look like? And that's something that's kind of an idea that's founded in photography and photorealism. And here we have a pretty photorealistic representation of the model. It's in diffuse light. This is more or less what it might look like in the gallery. Slight amount of specularity and sheen on the surface of the model. But with a 3D viewer like this, an explorer like this, we can manipulate it and do quite theatrical lighting. We can use the occlusion mapping to pump up detail that is on the surface. And what I want to stress here is that there's nothing inauthentic about this. This is just another visualization of the same accurate data set that we've uploaded to the viewer.
So at this point, should we load the crab? Or?
Just want to show off one more trick we have. We have a something called a 2.5D viewer. And what this allows us to do is we can no longer rotate the model, but what we can do is actually zoom into the level of detail that we actually captured with our scanner. And even though we're in sort of a 2D world, we can actually still interactively relight the object. There's still depth information. We can investigate using height profile tools. And now I'm going to pull up another model.
Our inability to, for years we've been able to scan Smithsonian objects at extremely high resolution, but we couldn't really share that with the world. We would take a screenshot and throw that up on Twitter or Facebook. Now, with the two different functionalities of this 3D Explorer, being able to dive in deep, tell a story with the 3D viewer and also the 2.5D viewer where we can see the true resolution and still manipulate surface properties, lighting. We can pull out detail that we just couldn't do any other way.
So those are all the ways that you can sort of freely investigate the model, but we wanted to make sure that this is a true storytelling tool. So you can click this first button on the menu, and you actually get tours. And again, this is how we're actually presenting today. But in general, this is a very user-friendly way for anybody to engage with these models and get peripheral information to the 3D data. So all I need to do is press the arrow key. And on the right-hand side, we have a reader that you can display text, images, embedded YouTube videos, links, all the other documentation that you might want to have, because 3D documentation shouldn't live in a vacuum. It needs to be complemented with all the other options out there. So this is a tool that's at our curators and educators' disposal right now. They can create tours, any number of tours for any given object. And in the future, one function that we really want to have is to unlock that so that anybody, anybody who wants to create their own tours for these objects will be able to do that on their own and then share that with their friends.
So that self-authoring could be a really amazing tool. Imagine that in a school system. So a teacher in Wisconsin being able to access Smithsonian collection objects in 3D, getting access from the knowledge of the curator for that object, but also being able to create their own tours. They can use that as their own teaching tool. So that is not yet implemented in the 3D Explorer, but we see that as phase 2. That's where we want to go with this. Or imagine students being able to, instead of creating a book report, you are using the Smithsonian 3D Explorer to study an object and maybe to create a presentation. So you're learning about this object and presenting that to your classmates and even the world. So that's sort of where we want to go with this. So right now, Adam has the right flyer loaded. So Adam just demoed the way we can sort of be led down a path by a Smithsonian expert, but we're also able to learn freely. So we can rotate these objects around, and we could turn on the hotspot layer. And at that point, we're just learning on our own. We're clicking on hotspots that look interesting. When you click on a hotspot, you can call up more information. Right now, Adam called up some information about the 1903 Wright Flyer propeller and some text, but that could also be calling up audio of the curator talking about this object, or it could be calling up video. We should probably talk about embedding too.
Yep.
Let's talk about embedding.
That's next. Let's see. Pull up another model. So storytelling, there's sort of a free ability to investigate the object. But another really important thing, let me pull up my crab model, is shareability. And that's something else that we wanted to focus on. This is the internet, of course. So let's say I've been fiddling around with my model. I've set my parameters just how I want them. And I've pulled a measurement. I've made a discovery. And I want to share that with a friend or colleague that lives on the other side of the world. We have a sharing button right here. And all you have to do is copy that link. And you can email that to a friend, and they will see not only the same model, but the exact same camera viewpoint, the exact same parameters set for the visualization, and the measurements that you've pulled. We took it a little bit further, and you can embed this just like you embed a YouTube video. So we wanted to make sure that Smithsonian X 3D website wasn't just a destination for content, but that we could proliferate that content on other people's websites, and other people could use this as a tool. And of course, we've got all the other sharing ability right here through other social media outlets. And how are we doing?
Yeah, I think so that wraps it up. At this point, we want to pass it off to the content experts. So at this point, we'd like to call up Dr. Peter Jacob, and he'll be talking about the 1903 Wright Flyer.